Good afternoon, everyone.
Good afternoon.
Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am.
Good afternoon. So today we'll be starting with our second book, that is the quantitative techniques. So the book 2 is about quantitative analysis. Now today we would be starting with the reading number 12. Let me just show you the index first before we start so that you know what all things we would be doing. So this is your book here. In this book, you have few chapters. So we'll start from this chapter. We'll start with study session 4 in today's class, where we'll be doing probability and statistics. So we have fundamentals of probability, random variables, then common univariate random variable, multivariate random variable. Okay, so this is the study session 4 that we would be doing in today's session. After that, we have sample moments and hypothesis testing, study session 5. Then in study session 6, we have regression analysis, which is linear regression and multiple regression. We also have regression diagnostics. So this is study session 6. And then in study session 7, we have forecasting, which is stationary time series, non-stationary time series. And then we have correlation. And the last part we have is simulation, bootstrapping, and machine learning. So these are the readings that we have from reading number 12 to reading number 26. So today mostly we'll be doing the study session 4 and we'll be covering these 4 readings and of course this one, sample moments. So this is the agenda for today's session. Okay, so let's begin.
So, ma'am, we will not make any notes as you told in the first class. So, just we are marking in the books. That should be ideal.
Yeah.
Right.
Because the syllabus is so lengthy, so if you start writing notes, then it would become very lengthy. Instead, if you can just mark there so that whenever you need read the book for the next time, you can see what is important. You can
Right.
highlight it there. Or if any concept you want to revisit, you can just write it by a pen or a pencil in a margin column that you have. So it will
Right.
make your book just like a note only. Okay. Fine. So let's begin with quantitative analysis. Okay. So here, the first topic is fundamental of probabilities, which is a basic chapter talking about probability. So we must know few things here. First, we must know what is a random variable. Then we must know what's an event. Then we must know probability in favor and probability against. So for example, coin. So coin is a random variable. And the event is that we are tossing a coin. Now in the coin, we could have a head and we could have a tail. So the head and tail are the possible outcomes. The probability of getting a head, if suppose I want the head, then the probability of getting ahead would be 1 by 2. And the probability of not getting ahead would be 1 by 2. So this is probability in favor and probability against. Now we must know the distinction between mutually exclusive events and independent events. So we just said that tossing a coin is an event. Okay, now whether is it a tossing a coin is an event, whether it's a mutually exclusive event or whether it's an independent event. So let us understand that suppose I am tossing a coin. Okay, can I toss a coin and can I throw a dice simultaneously? Can I do this simultaneously? Yes or no?
Yes, ma'am.
I have two hands. I can use to throw and one I can use to toss. Correct? So
Right.
I can do these two things simultaneously. So if you can make things happen together simultaneously, then these kind of events are known as independent events, which can occur together, which can occur together. Okay. Now I have an event where I can play football. I have another event where I also like to play basketball. So I like playing football also and I like playing basketball also. Can I play both games together?
No.
No.
Play both together? No. So because they cannot occur together, they cannot occur together. These kind of events are known as mutually exclusive events. Okay. So ones which can occur together are independent, which cannot occur together are mutually exclusive. Okay. Now we have if I talk about the independent event, okay, and can you tell me that if I toss a coin, then what is the probability of getting a head?
50%.
50.
So can I
1 by
write,
2.
yeah, 1 by 2 or 50%? And what
Right.
is the probability of getting number 5 on the dice? What
1
is
by
the
6.
probability?
1 by 6.
1
1
by
by
6.
6.
Yeah, yeah. So I have 6 events possible here, 1, 2, 3, 4, 5, 6, out of which I need 5. So which is 1. One event I want in my favor. So probability of getting a head is 1 by 2 and the probability of getting 5 is 1 by 6. Now both of these can happen together. So what is the probability of getting head and 5 together? So together will be equal to probability of head into probability of 5. So probability of head is 1 by 2 and probability of getting 5 is 1 by 6. So what would be the probability here? 1 by 2. This 1 by 12. This probability that I have calculated here is known as joint probability. Okay. So joint probability of independent events is calculated by multiplying the probability of each event. So probability of A and B is equal to probability of A multiplied by probability of B. 1 second. Yeah. So probability of A and probability of B will be equal to probability of A into probability of B. Okay. For independent events. Now let's talk about mutually exclusive events. So if I want to calculate here the probability of the mutually events happening together, then football and basketball. What would be the probability of football and basketball together? Can they occur?
No. No, ma'am.
No.
So therefore, the probability would be how much? Okay. So probability would be 0 because they cannot happen together. Okay. Now,
No, it is for mutual exclusive, correct, ma'am?
yeah. Okay. Now, suppose if I want to find the probability of uh, of playing football or basketball. Now, how can I calculate probability of playing football or basketball? So, I can play football or I can play basketball. But they cannot occur together. If they could have, there would have been possibility of them occurring together. I would have also subtracted probability of football and basketball. So I would have written, let's say, probability of playing football is 1 by 8 and probability of playing basketball is 2 by 3. Okay. So I would do here 1 by 8 plus 2 by 3. But this cannot be played together. So this probability would be 0. So probability of playing football or basketball will be calculated as probability of football plus probability of basketball minus probability of football and basketball. Yes, Ismail.
Sorry, ma'am, to disturb you. Ma'am, for these quantitative analysis and so on, should we use analyst prep notes or the Schwezer notes?
So, okay. So I see that many of these students were not there in my yesterday's class. So for their benefit, let me tell you that you have Schwarzer notes also, and you have analyst prep notes. Now, both of these notes are good. So they are like equivalent in the form of the content, in the form of how they are structured. Now it's a choice that analyst prep is only available online too. While Schwarzer note, you can get a physical copy. So now it's a matter of your choice. What do you like? Do you like to study online? Then analyst prep is enough. If you don't like to study online and you like to read through a book only, then you have. Hi, we have joined late as we are unable to see the live lecture link. So can you please tell what we have left, which is or it is basic concept. So, Shreyas, I've just started the class. Let me just give you a brief idea. See, the class starts at 2:30, between 2:30 to 2:35. So 5 minutes generally I wait. Okay. Yeah. So I just told that random variable means any variable. Like here I took an example as a coin. Then I said event. Event here is tossing a coin. Then probability in favor means if I want to have a head, then the probability of getting a head is 1 by 2. Probability of getting a tail is 1 by 2. So head and tail are all possible outcomes. And then I talked about two different types of events, mutually exclusive and independent, where I said that independent events are those which can happen together. They can occur simultaneously, while mutually exclusive do not occur together. And then I talked about How can I compute a joint probability? So probability of head and getting a 5 on the dice would be equal to 1 by 12. While if I want to calculate probability of playing football and basketball together, it is not possible, so it shall be 0. I can also calculate the probability of this or this in a mutually exclusive event, which will be equal to probability of football plus basketball minus football and basketball. Here football and basketball was 0, so we have put 0. But there could be mutually exclusive events which could have a joint probability given to you. If it's given, then you would always subtract it. So that is all I have done so far. Okay, anybody else has any question before I proceed? Because now I want to focus on the content. Anybody else has any operational problems? Okay.
Ma'am, can we use
So
study
let's,
material for the questions?
You can. There's no limit to what you can use.
Okay, ma'am.
Okay. Fine. Now let's move ahead. Okay. Now I can write an event like this, probability of A given B. Now what do I mean by this? What is the probability of A happening if B has occurred? If B has occurred, what is the probability of happening of A? That means, suppose if the event B is rain and the event A is a rainbow, then I'm saying what is the probability that I would be able to see a rainbow if it rains? If it rains, what's the probability of seeing a rain? Okay. So I write it as probability of rainbow given. How do I read this? It's not divided, it's given. Or you can read it as if. Probability of rainbow given it has rained, probability of rainbow if it has rained. And it is calculated as probability of rainbow and rain divided by probability of rain. Okay. This probability where you write probability of rainbow given rain or probability of A given B, this is known as conditional probability. This is known as conditional probability. And this probability here, probability of A and B, we just said that it's known as joint probability. And this probability of rain, where it is not dependent on anything, it's not multiplying anything, this is known as independent probability. Okay, so this is conditional, this is joint, and this is independent. So this is how you know the terms here. Okay. Now, suppose I give you a question that there is a dice. Okay, so you roll a dice and you get an outcome 3. By rolling a dice, you get an outcome 3. Is it an event? Yes or no? Is it an event?
Yes.
Yes.
Okay. If you roll a die and the outcome is an even number, is occurrence of the even number an event?
Yes.
Okay. Suppose you roll the die and you are getting numbers which are not 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6. Then is it an event? That means you are getting 1.
Yes.
So is it an event? Yes. Okay. For independent events, what is the joint probability?
0.
No, think again. For independent events, independent, which can occur together.
Multiplied.
Probability of A multiplied by probability
Probability
of
of
B.
Okay. Okay. One more thing here. If I am saying that rainbow and occurrence of having a rainbow and occurrence of having a rain, both of these events are independent events. Both of these events are independent events. In this case here, probability of rainbow given rain. Tell me which one is independent and which one is a conditional event.
Rain will be the
Rain is
condition.
Hmm?
rain is
Rain will-
independent.
Rain
Rainbow is
independent, rainbow
independent.
Yeah. So rain is independent
Yeah.
and rainbow is
Conditional.
conditional. Okay. So for conditional event, we said probability of A, where A is conditional event, over B, if B is given, is equal to probability of A and B divided by probability of probability of B. Now I am saying that the event A and B both are independent events. And then if I want to calculate probability of A given B, what do I get? What would be probability of A given B?
probability of A into probability of B divided by probability of B. A plus
No,
B.
you're not understanding my question. I'm saying here the A event, this one, was a conditional event. Therefore, I wrote to get the conditional event probability, I got probability of A and B divided by probability of. Now, A event is not conditional. What am I saying for A event? That it is independent. So if it is independent, then would there be a conditional probability of an independent event?
No.
No.
No. So therefore, probability of A given B would be equal to what? Probability of A only. Why? Because A is not a conditional event. And it is what kind of event?
Independent.
Dependent
It
event.
is independent. So when it is independent, for independent event, you don't have a conditional. Okay. So, yeah. Now, if I say that you are tossing you are throwing a coin, you are throwing a dice. So in a dice, how many outcomes do I have? 6 outcomes, 1, 2, 3, 4, 5, 6. And the probability of each of these outcomes is 1 by 6. Yeah. So probability of each of these outcomes is 1 by 6. Fine. This kind of variable where I can find the probabilities of a particular event, then this is known as discrete probability. Probability of an event is known. So I know probability of getting 4 on the dice is 1 by 6. I can put the sign equal to here. This kind of probability where I can put the equal to sign is known as discrete probability. Okay. Then I have Then I have, let's say I give you a diagram here. Okay, pay attention. Okay. So here I have a condition of my economy where GDP could go up or GDP could go down. The probability that the GDP could go up is, let's say, 60%. Tell me, what is the probability that GDP will go down?
40.
40%. So probability that GDP will go down is 40%. Now I tell you that if GDP increases, then the price of, let's say, ONGC stock, the price that ONGC stock will increase, the probability is 70%. And the probability that price of ONGC will decrease will be 30%. But if GDP decreases, then the probability that the price of ONGC will increase is, let's say, 55%. And the probability that the ONGC price will fall down is 45%. Okay. First, identify all the independent events. Can you tell me the independent events here?
GDP
Can you
up
tell
and
me?
down.
Yeah. So GDP going up and GDP going down.
No.
These are my independent. Okay. Now tell me, what are the conditional events?
All the price factor.
Yeah. So price going up, price going down. These are conditional events. Okay. Now, remember that if I take the probability of an independent event and I multiply with the probability of a conditional event, what probability do I get? What probability do I get? So if I say that the probability of A and B, how do I write probability of A and B?
PA
I
into
gave you a
PB.
conditional.
A into
Yeah.
probability.
PA into PB.
So I gave you the formula for conditional probability, wherein I said probability of A given B is probability of A and B divided by probability of B. I also gave you the joint probability formula of P of A and
Probability
B,
of
where
A.
it is probability of A and probability of B. Okay. Now look closely for both of these formulas. So probability of A and B is joint probability, and A and B are independent events. But it is not necessary that A and B would always be independent events. They could be a conditional event also. So if A is a conditional event, then instead of probability of A, what we have to write? Probability of A given B multiplied by what? Probability of B. This will give me the joint probability. Correct? So if you look closely, if I do probability of A given B into probability of B, what do I get here? Probability of A and B. So I'm saying that when you are calculating joint probability, you can calculate joint probability of two independent events also, and you can calculate joint probability of one conditional event and one independent event also. Okay. So here you have independent event and you have conditional event. Now, if you want to calculate joint probability of these, then how do you calculate joint? By multiplying these probabilities? Yes or no? See here, multiplying the conditional probability with the independent probability. Yeah. So now that is what I'm doing here. Can you tell me 60% into 70% would be how much for joint probability? 21%? 42%?
Yes.
Then 60 into 30? 18? Yes or no? And then 55 into 4? 22? And then 45 into 4? 18. So these probabilities are known as my joint probabilities, where I just multiplied 6 sevens are 42, 6 threes are 18, 55 fours are 22, like 4.5 into 4, 18. These are my joint probabilities. Okay. Any doubts still here? Any doubts still here? Did you understand how do I get the joint probability before I move ahead? Any questions? Any questions, anyone? Okay. So here, these are my joint probabilities. Now, why did I compute the joint probability? Now, I want you to find the probability that the GDP has increased and the price of the stock has also increased. What is the probability that GDP has increased and the stock price has increased?
42%.
42%.
42%.
Okay. Yeah. What is the probability of price increase, guys? What is the probability of price increase?
22%.
70%.
No. 70% is the probability of price increase if GDP has increased. 22% is the joint probability of GDP decrease and price increase. I'm asking what is the probability of price increase?
64.
64.
Yeah. So the probability of price increase is 42 plus 22. The probability of price increase is 64. And what is the probability of price decrease?
36.
36. Okay. So now you know the probability of price increase and the probability of price decrease. Now I have told you that I have given it to you that the price has increased. I have given this to you that the price has increased. Then what is the probability that GDP has increased? Listen to my question very carefully. Now, you know the probability of price increase. You also know the probability of price decrease. Now I'm telling you that I'm giving it to you that the price has increased. I'm telling that this has happened. The price has increased. Tell me the probability that GDP has increased. Do you get the question?
38%.
I'm telling you that the price has increased. So this is given to you. So I'll put in the denominator. And I'm asking you, what is the probability that GDP has increased? So due to price increase, the GDP has increased how much? 42%.
38.5, ma'am.
What 38.5?
The percentage of increase of the GDP if the price has increased. So 17 to 55, 8.5.
Sorry, I can't understand what are you saying.
Ma'am, would the answer be 66%?
Yeah. See, listen to me very carefully. I'm again repeating. I am telling you, I am giving it to you that price has increased. So you already know that the probability of price increase is 64. And now I am asking you that what is the probability that GDP has increased? So you know that GDP increase, the price increase due to GDP increase is 42%. Out of total 64%, 42% is the contribution of GDP increase. So you are looking at this probability here, 42 divided by 64. So how much would be 42 divided by 64? It would be somewhere like 65.6 approximately. So 65.6% is the contribution of GDP increase in the total price increase. So how much will be the contribution of GDP decrease in the total price increase? Yeah.
35%.
56%.
35. What is 56? $65 is 42 over 64. So 22 divided by 64 would be the contribution due to GDP decrease, the remaining one. Let me ask you one more question. What is the probability?
Sorry, ma'am. Sorry to interrupt you, ma'am. Shouldn't it have been for the probability that the GDP will fall? Shouldn't it have been the 42? I mean the 40% times the 50% divided by the 40%, which would give you 62%.
Sorry, I can't. Can you repeat?
So the question you asked was, what is the probability that the GDP would fall? Am I right?
The question I gave you is you are given that the price has decreased, the price has increased. So I'm asking you the question that what is the probability that GDP has decreased given a price increase? Probability of GDP decreasing given the price increase. This is my question.
Ma'am, is it 55%?
No. How 55?
You are asking about the GDP decrease, so I took the price, I took 22%.
Would be 22 plus.
First of all, what is the probability that price will increase? So price will increase, probability is how much? 64%. So I'll write 64 here. This is the probability of price increase. Correct or not?
Yes.
How much is the-
11.67.
Sorry?
11.67, man.
How 11?
Ma'am, is it
Ma'am,
62.5?
34 point.
ma'am, it would be 34.37%.
How?
22% divided by 64%.
Yeah. So 22 divided by 64. That is 34. Sorry, 24 point.
No, ma'am, 34.
34, ma'am.
24.4% shall be the probability. Because this 22% joint probability is happening due to GDP decrease. So therefore it would be 22 divided by 64. Now do you get it? Okay, let me ask
Yes,
you
ma'am.
one more and let us see that whether we really get it. So next one is, I have given you that the price has decreased. What is the probability that GDP has decreased given price decrease? What is the probability that GDP has decreased given price
Is
decrease?
it 50%, ma'am?
Sorry?
Is it 50?
50%. 50%. 18 divided by 36.
Yeah, correct. So total probability of price decrease is 36%, out of which the contribution due to decrease is 18%. So 18 divided by 36, when I do, I get 50%. Okay. Now do you understand? So this way of calculating the probability is known as Bayes theorem in your book. Okay. Okay, now let me ask you this question. Suppose if I give you here this probability that I was showing, if I would write it in the form of a function, then I can write that probability of x is equal to 1 divided by 6. Or I could write x divided by 6, where x can take values between 1, 2, 3, 4, 5, 6. Oh no. 1 by 6. So probability of x is 1 by 6, where x could be 1, 2, 3, 4, 5. So the probability of 1 is also 1 by 6, 2 is also 1 by 6. So I can write the whole thing in the form of a function. For probability, there are few rules that probability of any event can be minimum 0 and probability of any event can be maximum 1. It cannot be less than 0. It can be equal to 0, but it cannot be less than 0 and it cannot be greater than 1. So probability can never be less than 0 or greater than 1 for any event. Okay. Now I could also write the probability in the type of other function. Let's say I give you this function here. Probability of x is equals to x by 21. Okay. This is the probability function for a 6-sided dice. Okay. So we have a dice having 6 sides. And this is the probability function. Then what is the probability, which means probability of getting 1 would be how much? If I draw here, x and probability of x. So this is 1, 2, 3, 4, 5, and 6. So probability of getting 1 would be 1 by 21. Getting 2 is 2 by 21, 3 by 21, 4 by 21. Because the function is probability of x is x by 21. This is 5 by 21 and this is 6 by 21. There is one more rule to the probability which says that if I add all the probabilities, then the total of the probability should always come as equal to 1. Here also you can check 6 plus 5, 11, 11 plus 5, 15, 18, 19, 20, 21. 21 divided by 21 is 21. So if you do the addition of all the probabilities, it would always come as equal to 1. Okay. Yeah. Now what we are saying here is, this is probability. Now we are saying that what is the probability of x greater than? Now can you tell me what is the probability of x greater than 4? You know probability of 4 here as 4 by 21. What is the probability of x greater than 4?
Is it 6 by 21?
Greater than 4 means it could be 5.
by 21.
Yeah.
One.
It could be 5, it could be 6. So it could be any of these. When or word is used, then in probability we add it. So or word is used for addition and word is always used for multiplication. So here greater than 4 means probability of 5 or probability of 6. So if I do that, then I'll get 11 by 20. Okay. So this is one thing. Okay, let me give you one more question. The probability that the shares of one company will increase in value over the next month is 50%. Price increase 50%. So probability of price decrease would also be 50%. Now I'm telling you that, okay, the probability that shares of probability of A to increase is 50%. Probability of B and A both increase is, let's say, 40%. Probability that B will increase given A has increased is equal to how much? Probability of B given A would be equal to how much? Can you tell me if this is the information provided to you? Probability of A increases 50 and B and A is 40. How much would be the probability of A given A?
Is
B
it
given A. It would be probability of B and A divided by probability of A. So we'll have 40 divided by 50. That is how much? 90%. So probability that B will increase given A has increased is equal to 90%.
ma'am? Isn't it 80?
Ma'am, 80%.
80%.
Sorry, 80%.
80%, ma'am.
Yeah. Okay. Yeah, Sanskriti, this is your first lecture with me, I know. Yeah, I am aware that few students have joined my lecture for the first time. But of course, this is the first lecture of quantitative analysis. So I am taking our 3 books are completed. So only QA is left for you guys, correct? For the ones who have joined
can-
only today.
Ma'am, can you explain it again?
Yeah. Yes, Shen, definitely. Tell me, are you comfortable with the formula?
Yes.
Probability of B given A is probability of A and B. You can write it as A and B or B and A. It doesn't matter. Divided by probability of A. This is your formula for conditional probability. Correct?
Yes. Yes.
So you are having the probability of A and B and you have the probability of A. So just input this 40% divided by 50%. So you will get 80%.
Okay.
Yes, ma'am.
Sorry, ma'am, I just want to confirm, right? When you're doing conditional probability, you always divide by the independent one.
Yeah.
Okay.
Yes, that is what you do. Or you can remember it in the way that here A is there in the denominator, so we divide it by A. Because A is independent and B is already dependent. And you can learn it also in one more way, that probability of 2 joint events, A and B, would always be equal to probability of A and B. Now this event A could be an independent event also, or it could be a conditional event. If it's independent, you will write it as A. If it's a conditional event, you'll write it as A given B. So if you can just look closely, probability of A and B is A given B into B. You rearrange it, you'll get the same thing. Probability of A given B will be A into B divided by B. Getting the point? Are we doing calculations using BA2 plus calculator? No, we did not even touch the calculator. Whenever it's required, I will tell you. But yes, we will do it on BA2 plus only. Okay. Now let's understand. The function again. So the function that I have given you, I'll write the function here, x, and then we had probability of x, where x was 1 x by 21. The probability of x was x by 21. And x was between 1 to 6 because we were throwing a dice. And we got this function here. Here we get 1 by 21, 2 by 21, 3 by 21, 4 by 21, 5 by 21, and 6 by 21. Okay. Now I could create a cumulative probability table also. So cumulative probability I denote as F, capital F, and then I write in the bracket X. Cumulative probability as capital F and X. So how do I accumulate the probability? So probability here would be 1 by 21, then 1 plus 2, 3 by 21, then 6 by 21. I'm adding. So I'm adding 15 by 21 and this would be 21 by 20. Every time when I do the cumulative probability, the last item will always be equal to 1. This is the ground rule of probability. Okay. And it is denoted as f of x, where f denotes the cumulative. And then I used the word discrete probability. So whenever I could write probability of something is equals to something, whatever it is, as soon as I use the sign equal to, this is known as discrete probability. Then there is one more probability, which is known as continuous probability. Now in continuous probability, I could have a probability function. I could have a cumulative function. But the probabilities that I have are not equal to a particular point, but they are between 2 points. So let's say this is A, this is B, this is X1, and this is X2. So I have given you the probability of the event happening between A and B. Probability is between A and B. The probability is not at A, the probability is not at B. The probability is between A and B. Okay? Probability is between A and B. The probability is between A and B. Okay? So now A and B, you can say this X is between A and B. X is between A and B. X is not equal to A, X is not equal to B. So I will give you the probability of X between A and B. And I might ask you probability of X between X1 and X2. So I could give you like this. This is an event here. 0, right here. 2, 3, 4, 5, and 6. So I've told you that X lies between 2 and 6. So I've given you X is lying between 2 and 6. And I'm asking you that what is the probability of X to be between 3 and 5? Okay. And I've also told you one more thing, that this is a uniform distribution. So first thing, continuous distribution does not have equal to sign. Second thing, uniform distribution means I will count how many gaps here, 1, 2, 3, and 4. Total probability is equal to 1. Now 1 has to be divided into 4 parts. So therefore, for each part, how much is the probability? 0.25. So from here to here, 0.25, from here to here, 0.25, 0.25, and 0.25. Okay. Now, can you tell me what is the probability of X to be between 3 and 5? What is the probability of X to be between 3 and 5? Guys? Between 3 and 5.
0.5.
0.5. That is 50%. So 50% probability of X to be between 3 and 5. Because between 3 to 4, it is 0.25, and between 4 and 5, it's 0.2. So continuous distribution is that distribution in which you would not be having the probability at a particular point, but in between the points. A uniform distribution is one which has same probability. Like the dice example that we had taken earlier here, this one. This distribution. So this is discrete probability, but what kind of discrete probability? Uniform. Why uniform? Because each probability is equal to the other. Therefore, it is discrete uniform. Why is it discrete? Because I know the probability at 1 is 1 by 6. At 2 is 1 by 6. This is discrete. But if I look at this example, this is also of a dice only, where the outcomes are 1, 2, 3, 4, 5, 6. And I can write probability of 1 is equals to 1 by 20. So it is discrete in nature. But is it uniform? Are all the probabilities same? Are all the probabilities same here? Yes
No.
or no? No. So therefore, it is non-uniform. So discrete distribution you saw, which is uniform also, which you saw non-uniform also. And then you saw cumulative function of discrete probability. Then you saw continuous probability. And you saw continuous uniform probability. Now again, I can draw one more diagram like this. And I can give x values between 2, 3, 4, 5, 6. But between 2 to 3, the probability is 0.2, here 0.3, here 0.25. So how much here? 0.25. So what you can see, is this continuous distribution? Yes or no?
Yes.
Is it uniform distribution?
No.
No.
So this is continuous distribution, but it is not uniform. Continuous, but not uniform. Okay. If I would want to create a cumulative function, then between 2 to 3 is 0.25. So cumulative here would be 0.25. Cumulative here would be 0.5, then 0.75, and then here 1. So I can create cumulative and continuous also. For uniform continuous also, I can create. This is 0.2, this is 0.5, this is 0.75, and this is 1. So I can create cumulative function, which is denoted using f of x. This is my cumulative function for all the 4 different types. So we studied 4 types: discrete uniform, then we have discrete non-uniform, then we have continuous uniform, and we have continuous non-uniform. This is uniform and this is non. Okay, so these 4 types are there available. Okay. Now, if I draw this diagram here, yeah, any questions? Somebody saying something? Okay. Now I have given you, this is GDP increase, this is GDP decrease. Then I have told you this is stock price increase, this is EPS increase, this is EPS decrease, this is again EPS increase and decrease. And this is the new item that I have given you, the EPS number. So I have told you that EPS would be 2. Okay. The probability that GDP will increase is 70%. The probability that EPS will increase is 60%. And if EPS increases, then the EPS is 2. Similarly, I told here EPS is 1.5, here 0.9, and here 0.6. Now I want to know that what is the expected EPS as of today? As of today. So as of today, what is the price of EPS? That is what I want to calculate. Now, how do I do that? So for doing this, the first thing I need to do is I need to compute my joint probability. Can you tell me the joint probability for each of the 4 items? What would be the joint probability here? 42%, 6 sevens are, then
28,
28%.
60, 24.
so add and check, are we getting 100 or not?
Yes, ma'am.
30 and 60 and 10. You're getting 100. Okay. So now you have the joint probabilities. Now what do? You multiply the respective joint probability to the EPS number and then add them together. The value that you get is the expected value of your EPS. So there is 42% probability that you will get 2. So you'll do 2 into 42%. 22% probability of 1.5 and so on. How much are you getting?
For the first one, 0.84.
Okay. Solve and tell me the final answer. This is 42, 28, and then 6, and then next.
1.458.
What is 1.458? Yeah, final
Final
answer.
answer, ma'am.
Yeah. So 1.458, if we round it off to 2 decimal places, we'll be getting 1.46. So what is the expected EPS? $1.46. Okay. So this is how you go about finding the expected value. So always get the expected value. We take the joint probabilities and we multiply it with the respective probability, with the respective number, basically. Okay.
Ma'am, can you repeat once how 1.458?
I did 42% into 2 plus 28% into 1.5 plus 6% into 0.9 and plus 24% into 0.6. Together, 1.5.
Okay.
Okay, so this is how you get your expected.
So, ma'am, what we call this is a cumulative formula for the bears, or
This is expected probability. This is not base. This is expected value of the variable. Okay. This is the expected value of the variable. Yeah. Now tell me. Any problem till here? Anybody has? So I explained you few things like what is a event. So if you start from the beginning here, what's an event, mutually exclusive independent events, joint probability, conditional probability, Then we did discrete probability, discrete uniform, discrete non-uniform. Then we did continuous probability, continuous uniform, and continuous non-uniform. Then we talked about this tree diagram through which we can calculate probabilities. And then through this tree diagram, we can also calculate the, through this tree diagram, we can also calculate the expected value. This is what we have done so. Any doubts still here? Any doubts still here?
Ma'am, can you please explain again the probability of independent and the conditional one, the formula?
The probability of independent event. So any independent event probability is equal to the probability of the independent event only, because it is not conditional, so it will not depend on anything. What is the probability of me drinking water? It is not dependent on anything. So probability of me drinking water will be equal to probability of me drinking water. It is not dependent on anything. Okay. What is the probability of me not eating? So what is the probability of me not eating? It depends on whether I have eaten earlier or not. So when probability of not eating is calculated, okay, then I would calculate probability of not eating as probability that I have already eaten and I am not eating divided by probability that I have eaten earlier. This will give me the probability of not eating. And this non-eating probability is my conditional event. Now do you get it? So the formula can be written
Yes,
like
ma'am.
this. Probability of A given B, because it's a conditional event, will be equal to probability of A and B, because it's talking about joint, divided by probability of B, which is an independent. Okay. If I tell you like this, that probability, the probability of the GDP growth rate, this is X, the probability of GDP growth rate. This is GDP growth rate and this is the probability of the GDP growth rate. So probability that GDP growth rate will be 4%, probability is 10%, 3, 2, 1. These are the GDP expectations, and 30, 40, and 20. 6, 70, 80, 90, 100. Yeah. So these are the probabilities. I'm expecting that the 10% chance of probability of GDP to be growing at 4, 30% chance of GDP to be 3, 40% chance of GDP to be 2, and 20% chance that the GDP will be 1. Okay. So these are the GDP growth rate expectations, probability distributions that I have created. Now, can you tell me that how much GDP can I expect? What is the expected level of my GDP? Can you tell me? How would you get expected level of GDP now? So expected level of GDP will be calculated as 4 into 10 plus 3 into 30 plus 2 into 40 plus 1 into 3. How much are you getting? Calculate.
2.32%.
Yeah. So 2.32 is the probability. Okay. Now, generally, If I talk about mean, then how do you get the value of mean? Add all the values and divide it by the total number of observations. This is how you'll get mean. Correct or not? Yeah. You can
Yes.
calculate the average value by adding all and dividing by the number. Now, here, 1 second. Yeah. So, mean is calculated as adding all the values and dividing it by the number of observations. If I want to calculate standard deviation, then how do I get standard deviation? So, it's like I have put values of x. Let's say I have put up average marks of a class. And these are the average marks: 20, 30, 40, 50, and 60. These are the average marks in a class. If I calculate the average of this, then mean would be equal to 40. Mean would be 40 here. Now, I want to find out, this mean is basically a return concept. So it tells me that on an average, the students in a class score 40 marks. Or if I say that these are the stock prices in the last 5 years, then I can say on an average, the price of the stock in the last 5 years is 40 rupees. Now I want to find the risk concept. So the risk concept is known as standard deviation. Standard deviation. Now what is standard deviation? So standard deviation means that how much risk or how much do you deviate from your centric value? Your centric value is x bar. Now, how much do you deviate from your centric value? Are you very far from your centric value, or are you very near from your centric value? Here, this is near and this is far. So to understand the nearness of all these x's to its centric average value, we calculate a measure which is known as standard deviation. And it is calculated as x minus x bar whole square. So what do we do here? This is x 50, 20. So 20 minus 40 minus 20. Square of minus 20, 400. Square of 10, 100, 0, 100 and 400. If I add all of this together, I get 1000. Now, standard deviation is calculated as the square root of variance, where the formula of variance is x minus x bar. Square this first. First do the deviation. This part is deviation. Then square the deviation. So this is known as square of deviations. And this is known as sum of squared deviations. So square the deviations and then sum it. So you'll get sum of squared deviation and then divide it by n minus 1. This is variance. And when you square root the variance, see, you had squared it here. So now you will check using square root. So square root is known as standard deviation. Okay. So this is known as variance, and square root of variance is known as standard deviation. It is also known as a measure of dispersion. Standard deviation is also known as a measure of dispersion. How dispersed? How dispersed is the data from its centric value? How dispersed is the data from its centric value? Okay. Then if I take this data and I try to plot it, where these points are my X points. So here, this is my central value, X bar, which in our case was 20. Here, we had 40 as our average value. And then we had values below the mean, which were 20 and 30. And we had values above the mean, which was 50 and 60. So this is 50, this is 60, this is 30, and this is 20. So these are the points that I have plotted. Okay, these are the points that I have plotted. And if I join these points, using a freehand, then I am able to draw this curve. This curve is known as normal distribution curve, also known as Z curve. Normal distribution curve or Z curve, wherein the points are now extended and put down on the number line. So this point is 40 now, representing the average value. So I can find out that how dispersed the values are from the mean towards the left side also and towards the right side also. Okay, so this is normal distribution curve, also known as Z curve. So Z curve says that generally all the values are symmetrically distributed. They follow a symmetric distribution, which means this is 40 and this is 50. Now the deviation between 50 and 40 is 10. Here also this is 40, this is 30. The difference here is 10. So because the difference is 10, be it positive 10 or be it negative 10, it does not matter. What matters is that if there is 20% probability that there will be a deviation of 10 here, okay, then there'll be a 20% deviation on the left side also for values till 30. So you can say that there is 40% probability that the average values will be lying between 30 and 50. So a symmetric distribution means which is symmetric from its mean. So be it left side from the mean or be it right side from the mean, the probability would be same. So you can say same probability. You can see same probability. Okay. Similarly, if I would have drawn the distribution like this, again, this centric point is my, this centric point here, this centric point is my mean value. Okay. Now there is 50% chance that the values would be below the mean and there is 50% chance that the values would be above them. So the whole probability under this normal distribution curve is equal to 100%. This is the probability under this normal curve. And why is it a symmetric distribution? Because you can see that the mean divides the whole distribution into two equal parts. Both side, left side and right side, you have equal probabilities. Now, if I take my normal curve and just imagine that this normal curve, you have this curve here. This curve, imagine like a thread. And right now you have placed your thread like this, which is very symmetric in nature. Now I want you to pull the thread towards your right. Imagine and pull the thread towards your right. If you pull it towards the right, then what will happen? You don't have to completely pull it and flatten it out. But if you try to pull it your side, then you know how would it appear? It would appear something like this. Okay. So here, if I distribute it from its mean, what you can see that it is no longer symmetric. You can see non-symmetric. And you can see more values are there on the right side because I had pulled the thread towards the right. So this mean which was here lying at this point, it would have gone somewhere else. This point in the normal distribution, this peak point was my X bar. Now if I pull the thread, then this point would have gone here in the thread. So my X bar would be somewhere here. Okay. Now this normal distribution is quoting values on the number line, and the number line takes any values between negative infinity to positive infinity. Okay. So now if the distribution has become non-symmetric, it is also known as a skewed distribution. This distribution right now is skewed towards the right. So the distribution is skewed towards the right. In a normal distribution, you assume that this centric point mean is a point where mean, median, mode, all 3 points are equal. But in a skewed distribution, everything changes. So your mean is somewhere here, your mode is somewhere here, and your median is somewhere, or let's see. Your median is somewhere here and your mode is somewhere. Median is basically a centric value which is not affected by extreme observations. Mode is the number which is occurring for the maximum number of times. Number of times is important. The number which is occurring for the maximum number of times, that is the mode. Okay. So this is mean, median, and mode. Mean, median, and mode here. Where mean you can see has fallen towards the right, and right is positive infinity. So basically here in a skewed distribution, your probability of earning returns or greater returns has increased because the mean has shifted towards the right. So you would make greater returns for greater positive returns for distributions which are skewed towards the right. Similarly, take this thread again. Now I want you to pull the thread towards the left. So what will happen? The thread would go like this. So because the thread has been pulled towards the left, now what will happen? This point here, again, the top point would become your mode. Here somewhere you'll be having your median, and here somewhere you'll be having your mean. So this is again non-symmetric in nature, but this is skewed towards the left. So therefore, the probability here is to make negative returns or less returns. So for those distributions or for those stocks, if you're monitoring stocks and you can see that average returns are lower, then you can expect that, if you can see that that is skewed towards the left, then you can estimate that yes, yeah, less profit and they would be less, giving you less returns. Okay. So skewness, like standard deviation, is calculated as x minus x bar. First, you calculate the deviation. Now, in standard deviation, what did you do? You squared the deviation, totaled it, divided by n minus 1, and square rooted it to get the standard deviation. But in skewness, what do you do here? You take x minus x bar, okay, whole cube it. And now you divide it by sigma cube. And you add it, of course. So you take x minus x bar whole cube, you add the sum of these deviations, sum of the cubed deviations. So here you have sum of the cubed deviations divided by the cube of standard deviation. Sigma is standard deviation. Sigma square is variance. We said that standard deviation or sigma is square root of variance. That means it's square root of sigma square. So square root of sigma square is your sigma. Okay. Yeah. So skewness is calculated using this formula. X minus x bar whole cube divided by sigma cube. If a distribution has a skewness of 0, it indicates that it's a normal distribution. Because in normal distribution, what did we say? That it is symmetric in nature. A symmetric distribution, would it have any skewness? No skewness. So if it does not have
Hello, ma'am.
any skewness, then the skewness will be 0. Yeah, hello.
So, ma'am, can you derive the formula of the variance one?
Sorry?
The variance. The formula which you use as a variance, the skewed one, the latest one.
This is variance formula. There is no variance for skewness.
Okay.
Variance formula is only one formula, one single formula for variance. One single formula for standard deviation, one single formula for skewness. There are no two formulas. This is skewness. This is the formula for skewness. This is the formula of standard deviation. If I just remove the standard deviation square root sign here, this formula is variance.
Okay.
Ma'am, here for skewness, it's sigma cube. So that's like standard deviation cube. So,
Yeah.
so we have to put the same formula like variance x minus x bar square and minus 1, and whatever value we get, we will cube that value.
No, first this is variance. So
Yeah.
variance is sigma square.
Yeah.
First you have to square root, then you have to cube.
Okay. Whatever value we get, that we will make the cube of that.
Yeah.
Okay. Thank you.
Okay. Now let's talk about again the normal distribution. So this was a normal distribution. In the normal distribution, we have skewness equals to 0, and this is our mean, median, and mode all. This distribution is also known as mesokurtic distribution. Normal distribution or normal curve, which is also known as Z curve, is also known as mesokurtic, M-E-S-O, mesokurtic distribution. Now, what do we mean by mesokurtic distribution? That it does not have a peak, nor does it have a plateau. Here, it is not steep like this, and it does not have a plateau like this, but it is normal in nature. So this normal is known as mesokurtic, which means it has kurtosis equal to 3. The kurtosis is 3. For a mesokurtic distribution, the kurtosis is 3. Like for a distribution which is not skewed, for a normal distribution, how skewness is 0. So for a distribution which is mesokurtic, that means which is normal, which does not have a peak nor a plateau, the kurtosis of that distribution is 3. We also calculate one measure in kurtosis, which is known as excess kurtosis. So excess kurtosis is calculated as Ek is equal to K minus 3. Excess kurtosis is calculated as K minus 3, also known as Ek, excess kurtosis. Now for a normal distribution, kurtosis is 3. So if I calculate excess kurtosis, 3 minus 3 will be equal to how much? 0. So in a mesokurtic distribution, kurtosis is 3 and excess kurtosis is 0. And this distribution is also known as a normal distribution because it neither has a peak, neither has a plateau.
So how 3 is derived, ma'am? So is there any logic?
That is derived by some mathematicians.
I mean, how logically we need to correlate the 3?
Sorry?
How we need to correlate the 3 in a logical way? I mean, what is the reason having?
No, actually, there is a formula to compute kurtosis, and the kurtosis is calculated using this formula. I tell you, x minus x bar to the power of 4. Add it and divide it by sigma to the power of 4. This is how you get the number for your kurtosis. If you calculate this kurtosis for a normal distribution, then this kurtosis will always come as 3. This kurtosis will always come as 3.
Ma'am, is this kurtosis in our syllabus?
Yeah. Why would I tell you if it's not there in your syllabus?
No, like the derivation part.
No, no, no. Whatever I'm not teaching is not there in your syllabus. Whatever I'm teaching is there in your syllabus. If suppose I am not telling you derivation, that means it's not there in your syllabus. And of course, no derivations are there in your syllabus. In your whole FRM exam, did you study any derivations which are there in the exam perspective?
No.
No, right? That's right. You're not supposed to derive anything. It's an MCQ. Okay, now let's move ahead. So this is kurtosis. Yeah. So now as I was telling you here in kurtosis, that normal distribution curve is also known as mesokurtic. So this distribution curve which has a peak here, this distribution is known as leptokurtic curve. And this distribution which has a plateau here, this is known as a platykurtic curve. Now what you must know from these curves is that for a mesokurtic curve, we said kurtosis is 3 and excess kurtosis is 0 because excess kurtosis is always calculated as k minus 3. This is a generic formula that excess kurtosis is k minus 3. For a leptokurtic, it has a peak. Because it has a peak, so we say that the kurtosis is greater than. Therefore, the excess kurtosis will be greater than 0. While in a platykurtic, the kurtosis would be less than, and hence excess kurtosis would be less than 0. Okay. Now, what do we basically understand using this platykurtic and leptokurtic curves are? See here, if I draw the platykurtic curve, leptokurtic curve, and this is platykurtic. They both are symmetric distributions. First of all, we are talking about symmetric distributions, and we are not talking about non-symmetric. Okay, so here we are talking about the symmetry. in leptokurtic curve, you can see that this is known as the peak here, and this is known as the tail. So you have a left tail here, and you have a right tail. And you know that because this is a number line, the values would be between negative infinity to positive infinity. Okay. Now, if you look closely in platykurtic, you can see that many values are there in this range here. So what you can see that many values from here, from here to here, so many values are lying here, which means that we have high probability that there will be very less dispersion in the values. The values would be very concentrated towards the mean most of the times. And very low probability that there will be extreme gains, these or extreme losses. These are extreme losses and these are extreme gains. So we can see that there is low probability that there will be extreme gains or extreme losses. But if we look at this one, the leptokurtic one. So in leptokurtic, what we can see is that this is the tail, right? So here we are saying that most of the values are on the peak. Here. And then, but there is a very less, but there is a, okay. Here we have high probability and here we have high dispersion also, because see the values are in so big range in platykurtic. But in leptokurtic, values are here in the peak, but they have very less dispersion. That means very near to the mean, these are the values. So you have low dispersion. So high probability is there that there is low dispersion. And also you can see that many values are there on the tails, which means there is again high probability that there will be very extreme gains. There is probability that you can make extreme gains. So generally, if you look at stock market and if you want to advise your client regarding portfolio management, then you can see that if the curve that is formed is getting a leptokurtic design, then you know that there is high probability of being on this tail here. Okay. So leptokurtic curves are generally preferred by those kind of investors who are having the capability to take risk. They are willing to take risk because there is a probability of extreme gains. But of course, you can make losses also. So therefore, there is a risk. But in platykurtic, the market would not be very volatile. It would be here only in this range. So high probability that it would be in a particular range and you would not be making extreme gains or extreme losses. So platykurtic is described with that which is having thin tails and leptokurtic is having fat tails. So here we have fat tails and here we have thin tails. Okay. So for kurtosis, how do we calculate kurtosis? So did I tell you? Yeah. So kurtosis is calculated using this formula, x minus x bar to the power 4 divided by sigma. Okay. Now ask if you have any doubts here.
So, ma'am, in platykurtic, so there will be a less chance of gain and less chance of losses because there is a plateau. Correct, ma'am?
Yeah, low risk. It would
Low
act like
risk,
yes,
right?
yes.
And the
Yeah.
leptokurtic will be highly profitable and highly loss will be also there.
Loss would also be there. Yeah, there
Right.
it has probability of giving you high losses also.
And mesocortic is means 50% chances of both.
Yes, yes,
Right.
yes. Okay. Fine. Okay, now let me tell you this part. Of median. So median is generally like if there is a distribution, let's say X, and I write 10, 20, 30, 40, 50, 60. This is the distribution I have written. And if I want to find the median of this distribution, then how do I find? So I do n plus 1 divided by 2th position. This is 1, 2, 3, 4, 5, 6. N is equal to 6. So n is even. If n is even, then I do n by 2th position, which is the 3rd position, and n by 2 plus 1th position, which is the 4th position. So I take the values on the 3rd and 4th position and then I average them out. So 35 becomes my median. 35 becomes my median. Okay. If it's n is odd, then the median is on n plus 1 by 2th position. So suppose if n is 5, then 5 plus 1 by 2, that means 3rd position. The median is lying on the 3rd position. So median always would be found using a position. And the position generically you can take as Ln plus 1. If you are looking for median, you divide it by 2. But here you could be looking for, let's say, quartiles. Quartile. Now, quartile means dividing the whole distribution into 4 parts. So if you want to locate Q1, Q2, Q3, Q1 will be located as n plus 1, and because it is first quartile, and quartile is divided into 4 parts, so I'll do 1 by 4 into n plus 1. Q2 will be 2 by 4 into n plus 1, and Q3 would be 3 by 4 into n plus 1. These would be the positions where I'll get Q1, Q2, and Q3. Okay. Now, if I would have drawn a diagram like this, okay, where if you look at this data that I was giving to you earlier, the data between 10 to 60, this table here, 10 to 60, where we found the median as 35. So if this is the data, and I want to find the first quartile. So first quartile is n by n plus 1, and n plus 1 is 6 plus 1, 7, and 7 by 4. So what is 7 by 4? What is 7 by 4?
1.75.
1.75. So I'm looking at 1.75th position. This is first position and this is second position. Okay. The difference between them is 10. Now 10 is representing 1 point. So 0.75 will be represented by 7.5 points. So basically 17.5 will be my Q1. Would you agree? 17.5 to be the Q1. 17.5 will be the Q1.
Mom, can you repeat, please?
Q1 is calculated as n plus 1 divided by 4. My n is 6. So if I do 6 plus 1 divided by 4, I'm getting 1.75. Are you with me till 1.75?
Yes, ma'am.
Okay. So 1.75 means the first place value plus the 0.75th place value. So the first place value is 10, so I write 10. Now I need the value of 0.75th place. So I can see the difference between 10 and 20 to be 10 points. So 10 points is representing one place. One place is basically equal to 10 points. So how many points would 0.75 place be equal to?
7.5.
7.5 points. So therefore, 10 plus 7.5 when I do, I'm getting 17.5. Okay. So this part here, this diagram, I am saying this is my highest point, this is my lowest point, this is my Q3, this is my Q1, and the centric point here is my Q2, which is my median. So we just calculated Q1 as 17.5. Q2 we calculated as 35 and Q3 will be 3 by 4 of 7. So how much? How much would I get? 21 by 4 is 5.25. So 5.25 position. The fifth position is 50. Difference is 10. One place is representing 10 points. So 0.25 place will be representing 2.5 points. So 2.5 plus 50. If I do, then I get 52.5. So 52.5 is my Q3. My lowest number is 10 and my highest number is 60. So if I want you to tell me that what is the range of this data, so range is highest minus lowest equals to 50. If I ask you what's the difference, what's the interquartile range? Interquartile range means interquartile range means Q3 minus Q1. So how much is Q3 minus Q1 here? 52.5 minus 17.5. So how much are you getting? 35. So 35 is your interquartile range. This is your interquartile range. Okay, any doubts in this part? This question and explaining you the quartile, explaining you how to calculate the location, and then telling you this diagram wherein the highest minus lowest indicates the range and the difference between Q3 and Q1 indicates interquartile range. Yeah.
So ma'am, we can calculate Q3 minus Q2, that will be in between the ranges, correct ma'am?
Q3 minus Q2 does not have a significance basically.
Okay.
So you can say that Q3 plus Q2 divided Q3 plus Q1 divided by 2 is Q2.
Right.
Okay, Q3 plus Q1 divided by 2 is Q2 and Q3 minus Q1 is the interquartile range. Okay, and for the quantile function, you can denote the quantile function with this Qx. So if I write Q 25%, I am saying about Q1. If I write Q 75%, I am talking about Q3. So you can remember that quantile function can be denoted using Qx. Using Qx. Okay. And then you have a CDF function. So CDF is the full form is cumulative distribution function. The cumulative distribution function is the function which I told you already, f of x. This is cumulative distribution function. Okay. I want you to solve two questions. Just give me 1 minute. Yeah. And then you have a PDF. PDF full form is probability density function, which is P of x. So P of x is also known as PDF. Quantile function like a Q1, Q2, Q3 would be denoted using Q of x. The cumulative function f of x is also known as CDF. So these are different nomenclatures which are used from your exam perspective. So PDF is basically the probability distribution of all the possible outcomes. Okay. Okay, I want you to show this. Just 1 second. Yeah. Okay. So you can see this question here. Which of the following regarding a probability density function is correct? A PDF provides the probability of each of the possible outcomes of a random variable, can provide the same information as a CDF, describes the probabilities for any random variable, only applies to discrete probability distribution. Which one? A PDF, the probability function, P of x. Does it provide the same information as a CDF? Is P of x and f of x providing same information? Describes the probability of a random variable. Does it describe the probability of a random variable? Does the probability function only apply to a discrete probability distribution? Does it provide the probability of each of the possible outcomes of a random variable?
Can
Which one?
provide same information, ma'am.
You're saying B?
Yes.
Okay. So it provides the same information as the CDF. The PDF and CDF will definitely provide the same information, because if I have a cumulative function, from the cumulative function, can I find the probability? Yes. And from a probability distribution, can I find the cumulative function? Yes. So therefore, they both provide the same thing. And hence B shall be your answer choice. See, I'll tell you why A is not the answer. What is A saying? Provides the probability of each of the possible outcomes for a random variable. This is true if it's a discrete distribution. But a PDF can be made for a discrete distribution also and for a continuous distribution also. So providing the probability of each of the possible outcomes is not true for a continuous distribution, only true for a discrete distribution. It describes the probabilities of any random variable. Does it describe for any random variable? No. If again it is continuous, we can't describe the probabilities. We can only tell us probability between a range. It only applies to discrete. No. PDF applies to both discrete and continuous. And hence, B shall be your correct answer. Now do you get it? Why not A? For those who have mentioned A as the answer. That when it says provides the probability of each of the possible outcome of a random variable, it ignores continuous. But PDF and CDF are used both for discrete also and for continuous. Now let's look at the second question. For the quantile function QX. Sorry, you want to say something, Advait and Ravi?
No, ma'am, it's clear. Thank you.
Oh. The CDF function FQ 23% is 23%. Q 23% will identify the largest 23% of all possible outcomes. Q 50% is the interquartile range. X can only take on integer values. So they are talking about the quantile function. Q 23%. Q23, see, what does quartile mean basically? If I say Q1 is 25%, quartile, the Q1, I'm taking the values for 25%.
So it will be same, first one, I think so, because you have uniformly divided in the previously, like 17.5, 17.5 add-on, like it will be same. FQ
Correct.
23 equal to 23 will be ideal answer.
Yeah, correct. So when we are talking about the CDF function of FQ 23%, then what does 23% indicate? It is from 0 till 23%. So it is nothing but the cumulative function of 23%. And hence A shall be your correct answer. The CDF, as I told you, f of x. So f of x here is 23%. This is nothing but your quartile function of 23%, which says that from 0 to 23%, the values would be 23%. Why answer is not C? Q 50% is the interquartile range. No, Q 50% is the median. Interquartile range is Q3 minus Q1 and not the median. Median is Q3 plus Q1 divided by 2. So therefore C is not the correct answer choice.
Ma'am, please explain again why A is the answer.
When I talk about cumulative function, what does it mean? That values from 0 till 23% would denote my cumulative distribution function for the quartile for Q of 23%. Correct?
Right, ma'am.
What does cumulative mean from 0 to 23? Correct? And what does quartile function itself mean? So when I was calculating the quartile function here on our worksheet, we got Q1 of 17.5. What does Q1 of 17.5 indicate? The Q1 indicates that from 0 to 1, on an average, the values would be how much? They would be above 17.5. They would be above 17.5. Okay. So that is what is indicated using your cumulative also from 0 to 17.5. From 0 to Q1, how many values are there? 17.5. Q1 indicates what? That from basic till Q1, the number of values are 17. Okay.
Ma'am,
Hmm.
in the worksheet, we are getting like when we do Q3 minus Q1, then we are
Hmm.
getting the median. Then so why isn't C the answer then?
You are getting median because I have given you a very symmetric distribution. But
Oh,
that is
okay.
not necessarily true.
Okay.
Okay. Yeah. So I think now we can take a break. How much time break do you want? 10 minutes or 15 minutes?
15 minutes, man. will take.
Okay. So 4:35 it's right now, 15. So we'll arrive at 4:50.
Okay.
So I have few questions. Venus, what happened to our batch classes? Venus, I'm not sure which batch classes you're talking about because I have the responsibility to take the book 2 for your batch. Now, what happened to your earlier classes? What was happening there? What were you taught yesterday? I don't have any idea about it. So best what I would suggest is you can get to your student success manager and then you can call that person and ask these doubts because I do not have any knowledge about this. What I know is book 2 is my responsibility for your batch. That's all. Okay, so let's continue now. Yes, ma'am. Tell me.
Sorry, ma'am. If we have any doubts on like the Q&As on book 2, can we WhatsApp you our doubts or email?
So you can share any doubts you have. You have your student success manager. Just share those screenshots to them and they'll directly come to me. So you don't have to worry about them. And also we'll be having a doubt solving session. So you can keep accumulating your doubts and I would be only taking your doubt solving session. So then there also we can solve all the questions, doubts you have. Yeah.
Thank you, ma'am.
Okay, now let's move ahead. Okay. See, one revision again. If I tell you that this is a sorry, if I tell you that this is a cumulative, this is a continuous distribution function. This is a continuous distribution wherein the values are between 2 to 6, 3, 4, 5, and 6. Okay. And then I told you that this is uniform. So how did you find the probability of each term here? So you did 1, 2, 3, 4. 4 gaps are there. How did you found 4 gaps? You did 6 minus 2. What is 2 here? A. And what is 6 here? B. So to find the probability of each range, for each range, for finding the probability between each range, that is between, let's say, x1 and x2. Or to find the probability of x of between a and b. What did you do? You did 1 divided by b minus a. So 1 divided by 6 minus 2 is 1.
Ma'am, you have shared wrong screen.
Yes, ma'am, because
Oh,
we
sorry.
can't see where you're writing.
Now you can see.
Right, ma'am.
So I'm saying that the values are between 2 to 6. So 2 is your A and B is your 6. Okay. So if you want to find the probability of each of these distances, then how did you find? Orally, I asked you to do it. So what did you do? You counted the gaps 1, 2, 3, 4, and you divided 1 by 4. How you can do it using a formula? So you can see that 6 is your B and 2 is your A. So you will do 1 divided by B minus A, which is 1 divided by 6 minus, that is 1 by 4, which is 0.25. So 0.25 is the probability between each of these variables. Okay, this is uniform, continuous uniform distribution. Now you must know few things from this distribution here, that if you have a uniform distribution, if you have a uniform distribution. And for this uniform distribution, you want to find the mean and you want to find the variance of this distribution. So mean is calculated as A plus B divided by 2. In our example, we took A as 2 and B as 6. So we'll do 2 plus 6 divided by 2, which is equal to 4. So 4 is the mean of this distribution. You can see the center value is 4. What is the variance of this distribution? So for variance of this distribution, you do B minus A whole square divided by 12. This is the formula. So what is B here? 6. What is A here? 2. So 6 minus 2 whole square divided by 2. That is 4 square. 4 square is 16. 16 divided by 12. So when you do 16 divided by 12, you're getting how much? 16 divided by 12. So you're getting 1.33. So 1.33 is the variance of this distribution. 1.33 is the variance of this distribution. Okay. So these are the two formulas that you need to remember. Mean is calculated as A plus B divided by 2 and variance is calculated as B minus A whole square divided by 12. Okay. Now we are talking about another distribution, and that another distribution is known as Bernoulli distribution. Bernoulli. Now, Bernoulli distribution is a distribution which says that you can have only two possible outcomes. You can have two possible outcomes. That means you could have a success or you could have a failure. So basically two possible outcomes. Okay. Now probability of success can be denoted using P. So probability of failure would be how much, guys? If success probability is P, what would be the failure probability?
1 minus P.
1 minus P.
Yeah. So the failure probability would be 1 minus P. Okay. Now, here in Bernoulli distribution, we give the probabilities values. What values? Between 0 and 1. So if we give the probability of success, the value as 1, like how you have binary coding, no? In binary coding, you take values of 0 or 1, that is true or false. Similarly, in Bernoulli distribution, you can take P as 1. So then this failure would be 0. So you can give binary outcome to it. 0 and 1. Binary outcome to it. Okay. So if you are talking about a Bernoulli distribution, then the Bernoulli distribution is a distribution wherein the outcome can be 0 or 1. The outcome can be 0 or 1. Okay. So the mean of this distribution, if I want to put the mean of this distribution, it is equal to mu. We represent it using mu. Okay. And if I have to represent the variance of this distribution, then it is taken as P into 1 minus P. This is variance. And mean is nothing but the P value. So mean here is P and the variance is P into 1 minus P. Okay. Now in Bernoulli distribution, you do not have any questions. Questions would not be asked. Numerical questions won't be asked from you. You won't be tested on any practical questions here. Only you need to know the meaning. That Bernoulli distribution means two possible outcomes can happen where there is a success or a failure. Okay, and the mean is P and the variance is P into 1 minus. Now, we are talking about binomial distribution. In binomial distribution, we are talking about success or failure. Success or failure again. Success probability is P, failure probability is 1 minus. Okay. Now this failure probability I can also denote using another variable which is Q. Now the difference between Bernoulli and binomial distribution is that in Bernoulli distribution, we are only performing one single trial. Now what is one single trial? That if I suppose take a coin, I toss it once. That is one trial. Now in binomial distribution, what happens? I take a coin. But I toss it n times. I toss the same coin 50 times. I toss the same coin 100 times. So that n is my number of trials. Now in these trials, I want certain number of successes. So the number of successes are represented using x. These are my number of successes. Okay. So if I want to, let's say, talk about a coin. I know that the probability of getting a head on the coin is 1 by 2 and the probability of getting a tail on the coin. Oh. Let me take another event for easier understanding. Let me throw a dice. And let's see that the success is to get the number 6 on the dice. And the failure is not to get 6. That means I'm getting 1, 2, 3, 4, 5. So the probability of success would be how much, guys? What would be probability of success here? To get 6, what is the probability?
1/6 will be there.
1 by 6. And what will be the probability of failure?
5 by 6. 5 by 6.
1 minus P. So 1 minus 1 by 6, that is 5 by 6. So 1 by 6 is the probability of success and 5 by 6 is the probability of failure. Now let's say I am throwing this dice 10 times. So my number of trials is 10. And I want to have 7 successes. That means out of 10, I'm looking at 7 times to get 6 on my dice. Okay. So if I want to find this probability, then I need to know a formula. So the probability of x to be equal to 7 is equal to NCX P to the power x Q to the power n minus x. Now see here. What is n, what is x, what is p, what is q? This you guys know. Okay. Now what is this NCX? So NCX means out of 10, I need to select 7 outcomes where I would have success. So out of this 10, these 7 outcomes could be any 7. They could be any 7. So when I have to do a selection, then mathematically I can use a formula of combination, which is NCX, which is calculated as n factorial divided by x factorial into n minus x factorial. So don't worry, I'll just tell you. Suppose if I want to find 5C2. So what is 5C2? N factorial. So n here is 5. So 5 factorial divided by x factorial. X is 2. So 2 factorial. And then n minus x. So 5 minus 2, that is 3 factorial. Now how do I solve this? So 5 factorial is calculated as 5 into 4 into 3 into 2 into 1. 2 factorial means 2 into 1. 3 factorial means 3 into 2 into 1. So now I can solve this 3, 2, 1, 3, 2, 1, 2. Sorry. This is 3, 2, 1. So this 3, 2, 1, this 3, 2, 1 gets cancelled. This 1 is nothing. This 2 is 2. So I get the answer as 10. So 5C2 I can calculate as 10. Okay. In your BA2 plus calculator, also, I will tell you how to use this. So go to your calculator. Do you have your calculators downloaded? Either the
Yes, ma'am.
physical or...
Yes.
Okay.
Yes, ma'am.
So what you have to do is, you write 5 on the calculator, right? 5. Write 5 on the calculator.
Yes.
And then press second and plus sign. Second and plus sign. And then press 2. And then press equal to.
Yes.
Are you getting 10?
Yes. 10.
Okay. So
Ma'am,
second and
repeat
plus,
once again.
yeah.
Ma'am,
Suppose
can you repeat that? I am getting 70,000.
suppose if we have to find 9C7. So how to find 9C7? So first we'll write 9 on the calculator. Everybody write 9. Now press second and plus. Second and plus, not minus, plus.
Ma'am, 90,000.
And then press 7. And then press equal to. How much are you getting?
36.
Yeah,
36.
36.
36.
get 36.
Ma'am, what does the second function refer to?
You can see the plus sign,
Yeah.
and you can see that NCR is written above the plus sign in yellow or whatever color it is.
Yeah.
So whenever you have to use these second functions, in our laptop also we use a shift function to use that, correct?
Yeah.
So here second works just like shift.
Okay. Got it.
Ma'am, just one question. So for this NCX, N we took the value 10, and for X,
And we
uh,
took the value as 5. We did 5C2. 5C2 answer was 10. 5C2 answer was 10.
I mean, can you please let me know from where we selected this 5?
No, I'm not solving the question right now. I'm just telling you how to calculate
Okay.
NCX. If that is your doubt. We have not yet done the question. Now I'm coming back to the question. Okay. So now for our question, the formula is NCX P to the power X Q to the power N minus X. So for us, N is 10. So we'll put 10C7. X is 7. P is 1 by 6. So 1 by 6 to the power of 7. And 5 by 6 to the power of 3. Because we are looking for 7 successes and 3 failures. Okay. And we want to select any 7 out of the 10. So 10C7, tell me how much are you getting? 10C7, how much are you getting? 10
120.
and then C
120.
120.
120.
120.
So 120 into. Now solve this whole part and tell me the answer. So 6 to the power of 10 you will get, and 5 to the power of cube. So 5 cube is 125, and then 6 to the power of 10. So you can directly do 125 into 120 divided by 6 to the power of 10.
So ma'am, how will you calculate in power?
For power, you have y to the power x function.
So first 1 by 6.
So, no, not 1 by 6. You have 6 to the power 7 here and 6 to the power 3 here, right?
Right.
So total 6 is to the power of 10,
Okay.
and 10c7 is 120. 5 cube is 125. So you're left with 6 to the power 10 in the denominator. Yes or no?
Yes, ma'am.
Yeah. So this is there in the denominator. Now what do we do? So we have to solve 6 to the power 10. So I'll write 6, then press y to the power x, then press 10 equals to, I'll get a very big number. So I can store this number, store 0, STO 0. So this number has got stored now. Now I'll do 125 into 120 equals to, and then divide by recall 0, and then equal to. So I'll get 0.0002, something like this. Check if you're getting. Yes or no?
Ma'am, could you come again on how to work it on the calculator?
For 6 to the power 10, you have to write 6, then y to the power x, then 10 equals to. You'll get a very large number. Tell me if you're there till the large number.
Yes, ma'am.
If you're there till the large number, now we have to save this so that we don't have to input this again. So to save this, what do we have to do? We have to put STO and then press any number key, 0 to 1, any number key, wherever you want to store. So you can store values on numbers of 0 to 9. You can store 10 values in your calculator. So I am storing this number on the 0th key using STO 0. Okay. And then I am doing 120 into 125. So how much am I getting? 15,000? Yeah.
Yes, ma'am.
So 15,000, now I have to divide it by the big number I got from 6 to the power 10. So I do 15,000 and then divided by recall 0. Now what are you getting?
Ma'am, I got 0. Ma'am, I got 0.000248.
Yeah. So your calculator, you have to check that it's set on how many decimal places. My calculator is set on 4 decimal places. So therefore I can get 4 numbers after the decimal. If your calculator is set on 2 decimal places, so you'll get 0.00. How to set your calculator for 4 decimal places? So you have to go to second and decimal. Second and decimal. When you press second and decimal, you will see DEC is equals to. For some, it would be showing 1, 2, 3, 4, 5, 6, whatever. So now it's your wish, how many decimals you want. So suppose if I select 5, so select 5 and then press enter. Press enter. And then you can exit from here using CE/C. So C/C, you will exit. You will press C/C twice to exit and go to the main screen. And in the main screen, you will see now 0.00000. So this DEC function is used to set your decimal places using second and decimal sign. Yeah. Anybody else has a question here? Are you all getting 0.0002 now?
Yes, ma'am.
Yes,
Okay.
ma'am.
So this is how you use your store and recall function, and this is how you can calculate the probability for a binomial distribution. Now for a binomial distribution also, you must know the two values, the two formulas we learned for Bernoulli and for the continuous function, that is the mean and the variance. Here for the binomial distribution, the mean is calculated as n into p. For Bernoulli, it was only p. For binomial, it is n into p. For Bernoulli, the variance was p into 1 minus p. For binomial, the variance is n into p into 1 minus p. So same as Bernoulli, but only addition of n. Because here we were talking about only one trial, and here we are talking about n trials. Yeah. And here we are talking about n trials. Okay. So this is about expected value. This mean value is also known as expected value. Okay. Now we are talking about another distribution, and that distribution is known as Poisson distribution. Poisson distribution. This is not poison, snake poison. This is POISSON, name of a person, surname of a person. So, in Poisson distribution, generally we talk about those plants wherein defects are there. Generally for manufacturing plants, we use Poisson distribution. So if I say that, uh, number of defects are 900 per hour. Okay, so I am talking about per hour. When I talk about per hour thing, or if I talk about any per thing like per day, per minute, if I give a per date here, then I have a parameter which is known as lambda. So lambda is referring to expected number of successes per unit. Expected number of successes per unit. That is lambda. Let me first tell you all the functions here, where x is the successes again that you want to obtain. Number of successes that you want. That is x, like your binomial distribution. Okay, so let me explain this to you through a question only. That would be very easy. So suppose if I tell you that probability of getting x is equal to lambda into e to the power minus lambda divided by the x factorial. Okay, So lambda to the power of x, e to the power of minus lambda divided by x factorial. This is the probability distribution for a Poisson distribution. So if I explain a question, you would be able to understand. 1 second. Okay, so I'm telling that on an average, the emergency phone calls that are received on services like 911 is 0.1 incoming calls per second. 0.1 incoming calls per second. So every second we are getting 0.1 call on the emergency line. This is the rate of arrival of the incoming calls. Okay, this is the arrival rate. Now they are telling that assume that this arrival rate follows a Poisson distribution. The arrival rate follows a Poisson distribution. What is the probability that in a given minute, exactly 5 phone calls will be received? So how many successes do you want? 5. Exactly 5 calls. In how much time? In a minute. In a minute. So you are looking for in a minute how many calls would be received. So you know that there is 0.1 phone call per second. So if 0.1 phone call is per second, then how much would be per minute? How much would be per minute?
6
0.1 into
into
60.
60.
That would be 6. So I'll have 6 calls per minute. This 6 calls per minute is my arrival rate denoted using lambda. So lambda is also known as the arrival rate. Now I want 5 successes. So I'm looking for probability of x is equals to 5. And the formula is e to the power minus lambda into lambda to the power x divided by x factor. So e to the power, e is exponential function, to the power of minus lambda. So minus 6 into lambda. So lambda is 6 to the power of 5 divided by 5 factorial. This will give me the probability. So how do I find this on my calculator? You know that 6 factorial can be found using y to the power x. How do you find 5 factorial? So for 5 factorial on your calculator, you have a function which is known as n factorial. And you can see this n factorial x factorial. So you can see this function on the multiplication sign. So to find 5 factorial, you would write 5 and then you will press second and multiplication sign. Write 5 and press second and multiplication sign. How much are you getting?
120.
120. Because what is 5 factorial? It's 5 into 4 into 3 into 2 into 1, which is equal to 120. So you don't have to do a manual calculation. Directly, you can write 5 and then press second and multiplication sign. It will give you 120. Now let us see how do we find this part, e to the power of minus 6. So to use your e to the power function, you have e to the power x on your calculator. So e to the power x can be accessed using second and ln. Using second and ln. Because you can see above ln e to the power x is mentioned. Okay. So now let's see how do we find e to the power minus 6. So let's try e to the power minus 6. So what I will do? First, I will write 6. So first everybody write 6. First, write 6. Now press there is a plus minus key on your calculator in the last row near your equal to sign. So now press the plus minus key. As soon as you press it, you will see minus 6 now. Okay, because we want -6 here. So our x is -6. Now, to use the e to the power x function, I will press second and ln. So press second and ln. How much are you getting?
0.0002.
0.00248. Like if you have up to 5 decimal places. So this is how you get e to the power of -6. Okay. So now you know how to get the values for each of the three values. So what all values we have here to solve? It is e to the power of -6 into we have 6 to the power of 5 divided by 5 factorial. So 5 factorial is 120, e to the power -6 is 0.00248, and 6 to the power 5. Also we can find 6 to the power of 5, 7776. Now solve it and tell me how much are you getting.
0.1606.
0.1620.
Yeah. So 0.16. Now, if I want to write this probability in percentage, I can write it as into 100 I can get 16.07 something percentage.
So ma'am, 6 to the power 5, so I have to press 6 and yx, correct?
6 y to the power x and then 5. Yes.
Okay.
Okay. Any other, so you saw here that how this value can be calculated. Okay. So what does it indicate basically? This means that if the incoming calls are like 6 calls every minute, then there is 16.07% chance that there will be 5 incoming calls in a minute. So what does this 16.07% indicate? Chance that the number of successes will be achieved based on the current arrival rate. Based on the current arrival. Okay. Yeah. Okay, so this is about Poisson distribution. Then if I tell you that there is a distribution which is continuous distribution, okay, and the range of this distribution is, let's say, between between 12 to 28. What is the probability of an outcome to be between 15 to 25? If this is a uniform, continuous uniform distribution. The range is 12 to 28. So I've given you A and B. And now I'm asking you what is the probability between 15 to 25 if it's a uniform distribution. Find this. Tell me the probability, everyone. Yeah, I want water. Yeah, tell me. How much are you getting? No, not getting. So, see, remember continuous distribution. This is 12, this is 28, and uniform. So, how do I find probability? 1 by b minus a. So, 1 by 28 minus 12 is 1 divided by
0.0625.
16. So, 1 divided by 16 is how much?
0.0625.
0.0625. Now I want the probability between 15 to 25. So how do I find the probability between 15 to 25? So what do? I can use a formula here. Probability of x between 15 to 25 is equal to 25 minus 15 divided by 28 minus 12. How much are you getting? 10 divided by 16, which is equal to
0.625.
0.625. So this is your probability. So you can remember this formula also. Probability of x to be between x1 and x2 can be calculated as x1 minus x2, sorry, x2 minus x1 divided by b minus a. So therefore 25 minus 15 divided by 28 minus 12. So you got 0.625. Okay. So this is how you can get the probability. Okay. Yeah. Now let me tell you this part. In a normal distribution, this is how your normal distribution looks. This one. So in a normal distribution, this is your normal distribution, which is very symmetric in nature. Okay. So for a normal distribution, we must know few things. So I told you that this centric part is the mean. Okay. Now I have equal probability of values to be lying below the mean and equal probability of values lying above the mean. So I calculated standard deviation. Remember? So if I say that what is the probability that the values or the returns that I get would be between one standard deviation of mean. So what do? I plot here one standard deviation. This is minus one standard deviation. And this is positive one standard deviation. So what is the probability that the returns or the stock prices, whatever I am trying to forecast? Basically, why do I use distributions? To do forecasting, to take I take assumptions, and based on those assumptions, I do forecasting. So I'm talking about a stock price, or I'm talking about the returns on a stock. I have the average returns. I calculated the standard deviation of the returns. And now I want to find the probability. So here I'm finding the probability. What is the probability that the values would be between one standard deviation of mean? Okay. So the probability that the values would be between one standard deviation of mean are 68.3%. So 68.3% is the probability that the values would be between one standard deviation. So approximately you can say 68%. Easy to remember. Suppose if I ask you how many values, what is the probabilities that the values would be between two standard deviation of the mean? So this is minus 2 standard deviation, this is plus 2 standard deviation. So this whole percentage probability that we are talking about, this one, is approximately 95%. And if I say, what is the probability that the values would be between 3 standard deviations of the mean? Then this particular probability is almost 99%. Remember, the total probability under this curve is 100%, which is symmetric in nature. So 68% from here to here, that means 34% here, 34% here. 95% from here to here, which means 47.5% here, 47.5% here. Similarly, 99% means 49.5% here, 49.5% here. So confidence, this here, the deviations that we are calculating, this is known as confidence interval. So it's like I am 99% sure, I am having a confidence interval of 99% that the values would be between 3 standard deviations of mean. Then I can say that 95% is the confidence interval that the values would be between 2 standard deviations of mean. And I am 68% sure that the confidence interval is, I am 68% sure that the values would be within 1 standard deviation of mean. Okay. So this is the significance of normal distribution, that it can tell you the probabilities. It can tell you that you can be how sure that the values would be in what kind of range if you have calculated your standard deviation. Okay. Then you can also build confidence intervals of 90%, 95%, and 99%. So how can you build confidence interval? To build confidence interval, you would again need two things, the mean and the standard deviation. If the standard deviation that you use is of the whole data set that you have, then this standard deviation is known as population standard deviation. But if you use the data only from a sample perspective, then the sample standard deviation is denoted using small s. So this is small s here and this is sigma. Both are standard deviation. One is, suppose the stock is listed for last 5 years and you have taken the returns of last 5 years to calculate the standard deviation. Then that is population standard deviation. Now let's say the stock which has been listed for 5 years, you have taken data only for 2 years. So this 2 years is a sample, and the standard deviation you calculate would be known as sample standard deviation. So knowing this, you have a formula to get the values here. See, here you could only tell that I am telling that 68% probability that the values would be between -1 standard deviation to 1 standard deviation. But exactly 68% sure that the values would be in what range? I do not have an idea of the value. So now I can get an idea of the value also. So how do I get the idea of value? By using a formula, which is x bar plus minus, because it's an interval that we are talking about, plus minus a value of z into the standard deviation. If I'm taking sample, I'll write S. If I'm using population, I'll write sigma. Where x bar you know is the mean value and S here is the standard deviation. Now what is this value Z? So remember I told you that normal curve is also known as Z curve. So there are few values of Z that you can learn and remember. For 90%, the value of Z that you can remember is 1.645. Or you can also remember it as 1.65 also if you want 2 decimal places. Then for 95%, the value you can remember is 1.96, and for 99%, 2.5. These are the values that you should remember, like, because I will show you how to use the Z table and from where we got these values. But right now you can just remember. Also from exam perspective, also you can just remember these values. So if I am building a 90% confidence interval, I'll put Z as 1.65. If I'm using a 95% confidence interval, I'll put Z as 1.96. Otherwise, I'll put my Z as 2.5. So you can see here 1.96. What is 1.96? 1.96 is approximately 1.96 is approximately equal to 2. So we said that here 95% confidence interval that the value would be lying between 2 standard deviation. Now what does that mean? That is what you can see here. That 1.96 here is nothing but 2. So between 2 standard deviation. That is plus 2 standard deviation and minus 2 standard deviation. From where? From the mean. So x bar plus 2 standard deviation and x bar minus 2 standard deviation. So here in this question, if I would have given you that the x bar is 10 and the standard deviation you have calculated is 20%, this is 10%, then what would be your 95% confidence interval? Approximately, if you would have taken, you can take 2 standard deviation. So 2 into 20% is 40%, and your mean is 10%. So 10 plus 40 is 50, and 10 minus 40 is minus 30. So you are 95% sure that the returns of this stock would be lying between minus 30% to positive 50%. That is the implication or usage of normal distribution. That it can help you to find values and it can help you to find a confidence interval. That how sure you are that the values would be in that range. So you are 95% sure that this stock who's having an average return of 10% and a standard deviation of 20% will have returns between negative 30 to positive 30. And there is a 95% probability. Okay.
Ma'am, so are we actually finding the value address?
No, no, no. This is not VAR calculation. This is confidence interval.
All right.
This is confidence interval. VAR is a separate model only. It's a risk model. We are not doing risk right now. We are doing quantitative analysis.
Yes.
Okay.
Ma'am, in above example, what was the Z value? We took
Z I took because it's 95% confidence interval. No,
the
actual value is
yeah
1.96,
1.96. Yeah.
but I have taken 2 for easy calculation.
Okay.
1.96 is approximately equal to 2 only, right?
And X bar is 10. I
10.
mean, clear. Yeah. Thank you.
Okay, so this is how you build confidence interval, and this is how you can interpret these confidence intervals and remember the values also. Okay. Suppose if you do not have the value of Z, you do not have the value of Z. Why do you not have the value of Z? Because, you have your mean and you have your standard deviation. So for example, if I draw a normal curve here, the mean of my distribution is 10% and the standard deviation is 20%. Okay. Now I want to check that what is the probability that the return would be greater than 20%. So I want to check using my return as 20%. When my average return, how much is given to us? 10%. So I want to check this probability, this one. What is the probability that the returns would be greater than 20%? So by looking at the diagram, can you tell me that the probability would be greater than 50 or less than 50?
Greater than 50.
Greater than 50. Probability of return greater than 20. Just look at the shaded area. Where is it lying? This mean divides the whole distribution into 2 parts. So which is 50% each. So from here to here, this total probability is 50%. So for the shaded area, the probability would be greater or less than 50%.
It will be less than, ma'am, because already.
Yeah. Do you get the point? Why? Because the normal distribution divides the whole distribution from its mean into 2 equal parts, where each part is 50%. So if this total part is 50, then of course this part is smaller than the 50. So the probability here would be less than 50. So to find the probability, we have a Z table that can be used. To use the Z table, we need to find a Z value. And the formula for Z value is X minus X bar divided by standard deviation. Where X bar you have 10%. What is X? X is this value through which you have to do the comparison. So 20 minus 10 divided by 20. So you'll get 10 divided by 20, which is equal to 0.5. So the Z value that you have is equal to 0.5. Okay. So now you need to find the Z value. So how do you find the Z value? So you find the Z value through the Z table. So I'll show you the Z table now. This is Z table. This Z table, you can see it's written cumulative. This Z table is known as cumulative probability for standard normal distribution. So when it says cumulative probability, the table at 0, 0 will always start at 0.5. So what does cumulative mean? That this part from here to here is 0.5. Correct? So cumulative table says that it is including this left side already. It is including this left side already. So when at Z value of 0, you can see 0.5. So Z value of 0 indicates this point, which indicates that this hole is 0. This hole is 50%. In our case, the Z value that we have is 0.5. So for Z equals to 0.5. For the first decimal, we look below, and for the second decimal, we look in the row. So suppose the value would have been 1.65. Can you tell me 1.65 is how much? 1.6 and 5 for the second decimal place. Can you see how much? 0.9505. Remember that 1.65 is the value we learnt for a confidence interval of 95%. Confidence interval 95%, the value we learnt is 1.65. Now, the Z value, if you put 1.65, what are you getting? 95%. Similarly, you learnt 1.96 for 99%. Now look here, 1.9 and look here, 6. What's the value you're getting?
97.5.
Sorry.
97.
Yeah. This table is actually the cumulative table. So what does cumulative table say? The cumulative table takes into account the whole left side, which is the reason why we learned for 90% 1.65, but you are getting 95 from here. And we learned for 95%, we learned 1.96, but we are getting 97.5. You know why? I will tell you. That for 90%, this whole is 90. Okay. So this remaining is 5 here and this remaining is 5 here. Correct or not? What I am meaning to say, this is my normal distribution. So if 90% is the confidence interval, this whole is 90%. Being a symmetric distribution, remaining is 10%. So 5% will be here and 5% will be here. Now, the Z table is a cumulative table, which takes into account values from extreme left to the point where you have calculated. So from the extreme left to the point you have calculated, 5 plus 90 is how much? 95%. That is the reason when you are getting Z is equals to 1.65, the value that you are getting is 95%. Because from here to here, it's how much? 95. Similarly, if you are talking about Z is equals to 1.96, okay, then here I am putting 95% along the confidence interval. So I'll be left with 5%. This 5% distributed would be 2.5 here and 2.5 here. Now Z table again is a cumulative table. So it will tell me probability from here till here. So from here till here, how much am I getting? 97.5%. So now if you look at the table, you will see that for 1.65, you are getting 95. And for 1.96, you are getting 97.5. If this is clear for you, you only tell me that if the confidence interval is 99%, 99%. So this whole value is 99%. How much should I put on the left and how much on the right? Remaining is
0.5.
So 0.5 and 0.5. That means when I would be looking for the Z value of 2.58, what would I be seeing in the table?
0.995.
Yeah. So 99.5%. 99.5% I'll be saying. So 0.9950 I'll be saying. So let's see. If I put 2.58. So this is 2.5 and this is 8 here. So how much am I getting?
99.5.
0.995. Understood? that this is your Z table. You can find the value of Z and you can look in the table, or you can see the probabilities in the table. So basically the table tells you the probability. The table will always tell you the probability. In our example, we found Z as 0.5. So the probability we found was 0.6915. So what is 0.6915? Here, if we go back, 0.69, how much did we get? 15. Can you tell me this probability of 0.6915 is from where to where? What probability does Z table give you? From your extreme left till the point of comparison. So from here to here, the value is 0.6915. But we want to find the probability of this shaded area. So can you tell me how much would be the probability of this shaded area?
1 minus 0.691.
Yeah. So that would be 0.7085. Sorry, not 0.70. 3085. Yeah. So 30.85% is the probability of getting return greater than 20%. Using this data, there is 30.85% probability that the returns will be greater than 20%. Do you understand, guys? Do you get the point here? So
Ma'am,
this is
can you
your
explain again this one 30.85? Actually, we are solving this one. G, correct, ma'am?
we
So
are
x minus
solving.
x bar divided by standard deviation, correct? So it's
Sorry?
so the
Yeah,
formula is x
yeah,
minus x bar divided by standard deviation. So we are getting 0.5. So
yeah.
we are searching for the 0.5 value, that is 6910, and 1
Much better.
minus 6910 equal to 3085. That is the confidence level we are getting, that 30.85 will be the return.
30.85% is the probability
The
that the
that
returns will be greater than 20.
20. Okay. Got it.
Okay. So you know the Z table. Okay, simple. I'll give you one more question to check whether the Z table is understandable or not. I'm drawing a normal distribution curve and I'm telling here that the mean is 6 and the standard deviation is 2. What is the probability that the average value is greater than 9.7? Greater than or equal to 9.7. What is the probability? What is the probability that it's greater than or equal to 9.7? So what would I do here? This I will put as 9.7. Now I want this probability. Okay. So first I'll find Z, which will be 9.7 minus 6 divided by 2. How much are you getting? Calculate.
6.7.
1.85.
$1.85.
So you're getting 1.85. Okay. Now this 1.85, we have to look in the Z table. So if I look at the Z table, 1.85, then I'm getting a value of 0.967. So I'll put here Z value 0.967. Now, what does 0.9678 represent here? Tell me, what does it represent?
From extreme left till 9.7.
So the
Right?
total area, ma'am, it will be covering
From
1 minus
extreme left.
0.9.
Yeah.
So this pink area, the probability that the probability that the returns would be lying in this pink area is how much? 96.78%. So what will be the probability that the return would be greater than 9.7?
32.2.
32.2.
1 minus 9.9678, which would be how much?
32.2.
32?
3 point.
And 3
Ma'am,
point.
is it
3 point, ma'am.
3? I guess 3.
3.30.
3.2822. Correct? So 3.22 percentage is the probability that the return, whatever we have calculated, is greater than 9.7. Okay. There is one more concept here that you must understand. I could have asked you same question I would have given you. Okay. I would just change the numbers. So I would say this is again 6. Now tell me the probability that the EPS is less than 4.1. Standard deviation is again 2 only. How much would be your Z? 4.1 minus 6 divided by 2. That is
0.9.
1. Yeah. Negative 0.9. It's 4.1 minus 6. Because if I draw it here on the graph, where is 4.1 coming? On the left side. So the Z value that I'm getting is negative 0.95. So how do I find the value for negative 0.95? So for negative 0.95 also, you have to take the same table. For same table, you look at value of Z is equals to 0.95. So we will see at what is the value for Z is equals to 0.95. Second, just open the table. Yeah. This is the table. What's the value? 0.95, right? So 0.95 is 0.8289. So I'm getting the value from the table as 0.8289. This value I'm getting for Z is equals to 0.95 positive. So for Z is equals to negative 0.95, the value is 1 minus 0.8289. So how much is 1 minus 0.8289?
0.17.
0.0.
No, 0.1711.
0.1711.
So the value that I'm getting for percentage probability is 17.11. Now, what does this probability tell? This probability is from my extreme left to the point I have done the comparison for. So now I don't need to do any subtraction because I already got this value here. So what is 17.11? It is the probability that the returns would be less than 4. Okay. So anytime if the value comes negative, you don't have to worry because that value is nothing, that value can be converted into a symmetric distribution. Yes, Ismail.
Sorry, ma'am, can you just explain the last part why you didn't do the subtraction?
See, Z is 0.95. and Z is minus 0.95. So we are talking about a Z table which is symmetric in nature. So Z equals to 0.95. What does it indicate? Z is equals to 0.95 indicates the probability from this point to this point. Okay. This is the probability we are getting at Z is equals to positive 0.95. But what value of Z did we get? Negative 0.5. So what is negative 0.5? Negative 0.5 is just a reverse or an inverse of the whole Z. Because it is a symmetric distribution, Z is equals to 0.95 and Z is equals to negative 0.95. If the probabilities you calculate and the probabilities you add, this will always come as 100%. This is true for any value of Z. This is true for any value of Z because all the Z distributions are symmetric distributions. Okay? Yeah, Ismail?
Yes, ma'am, I got it. Thank you very much.
Okay. Then there is one more distribution, which is known as log normal distribution. So in normal distribution, we say that the distribution is symmetric and we could have values from negative infinity to positive infinity. It is not skewed. It does not have any excess kurtosis. And it is also known as a mesokurtic curve. It is a symmetric distribution. So all these things we studied for normal distribution. If I model out the prices of a stock, can I model the prices of a stock through a normal distribution? Yes or no? Can I model the prices of the stock?
Ma'am, the stock price is always random, so it is not symmetric.
No. Yeah, that is correct. But I am saying that although they are random, can I plot them to a normal distribution?
Yes, we can take a value and we can plot.
No, I cannot. You know why? Because look here, I can plot negative values on a normal distribution. Would the prices ever be negative?
No.
No. So therefore, do I model the prices through normal distribution? So the answer is no, I do not. So how do I how do I show the prices? So for prices, I use a log normal distribution, which is a distribution like this, which is bounded by z and gone to positive infinity. It is not symmetric. It is a skewed distribution, skewed towards the right. Because prices would not be near zero, but there would be somewhere away from zero. So it is skewed towards the right and it's not symmetric. Okay. So log normal distribution is a distribution generally used to model out the prices of a stock. So I do not want to scare you, but I still want to show you this formula. So there is like, if I want to show the probability function for a log normal distribution, then the function of log normal distribution looks like this. 1 divided by x into e to 1 divided by x into sigma square root of 2 pi into e to the power minus half into ln of x minus mu divided by sigma square of this. Okay, now we are not looking at derivation of this formula. This is how the probability function of a log normal distribution looks. Now, when would you use these things? When you would be studying your binomial distribution. So in binomial distribution, not this binomial that we studied, but a binomial option pricing model. So when you'll be doing your binomial option pricing model, that is the place where all of this would come, ln of x, mu, sigma, e to the power x, all of that. So right now, but because we are studying it right now, so I'm telling you that this is how the function for log normal distribution looks. I should also be
So,
showing.
ma'am, so it will be used in the book number 3, binomial upfront pricing, correct, ma'am?
Yes. If I want to show you the function for normal distribution, then how does the function of normal distribution looks? So you would be able to distinguish. Same, everything is same. 1 divided by sigma square root of 2 pi. Okay. Here I do not have x. Here I have e to the power minus half. Now x minus mu divided by sigma, which is your z, and square of that. The difference you can see is here you can see ln of x because it's a log normal distribution. Here you can see only x. Again, here you can see x, but here you do not have x. So that's the main distinction between log normal distribution and the normal distribution PDF function. So this is your PDF. Okay, coming back to the log normal distribution. So when is log normal distribution used? So log normal distribution is used to model the stock prices and to calculate returns on a stock using the stock prices. If you know the stock prices and you want to find the returns, then you can do that using the log normal distribution. Okay. So supposedly, if I want to find the return on a stock, I bought the stock for 100 and I'm selling it for 120. I was holding this stock for 1 year. So if I want to find the return on this stock, then I can find return is equals to ln of S1 divided by S0. So S1 is 120 divided by S0 and then ln of it. So basically, I have to do ln of 1.2. Now on your calculator, you can do ln of 1.2. So how do you do? On your calculator, you go and divide. On your calculator, you write 1.2. Okay. Now press ln. Write 1.2 and then press ln. Not second and ln. Only ln. So ln is log natural. So log of 1.2, you'll get 0.182. So approximately 18.23%. So how much return did you make in a year? 18.23%. Okay. This 18.23% return that you are making is known as a continuous compounded return. Continuous compounded return. So what is continuous compounded return? If supposedly I would have invested this money, the $100, at a hourly compounding rate for 1 year, and I would have made 120 by the year end, then how much return did I make on this investment? So approximately 18.2% return. Continuous compounding return is very close to an hourly rate of very close to an hourly rate of okay. Then we have three more distributions in this.
Ma'am, just 1 minute.
Yeah.
So you have taken the S1 is 100, 120, correct, ma'am?
Yeah.
And divided by 100.
Yeah.
So this is the given. Suppose I am taking a one stock, Reliance. Right now it's in 2500, 120. Hello,
Yeah.
2512. 2512.
255. Yeah.
So what will be the expectation? My expectation is 20% per year. So how will derive this one?
No, this is not deriving a price. Log normal distribution is not used to derive a price. Log normal distribution is used to calculate your continuous compounded return.
Means the value is already known.
Yes. See,
Okay.
I told you, no, 100 is what I put in, 120 is what I got. So what's the return I got? So generally you would have said that it's a 20% return, correct?
Right.
But based on continuous compounding, because the compounding is more frequent, it's like an hourly compounding. So the return is less. So 18.23% approximately. If compounded hourly, it will give you a return close to 20%.
Okay.
Okay. Yeah. So then you have many other distributions that we will be doing in our next session. Yeah. So meanwhile, in this whole week that you have, just try reading as much as you can from all the three readings that we have done. So we have completed the 12th reading, 13th reading, and we have done like a 60% of the 14th reading. So this is what we have done in today's session. You can go through all of this stuff, and then if you have any questions, then you can ask me in the next class.
Ma'am, can you repeat? Like my internet connection was gone.
What do you want me to repeat?
It's like you were telling about the chapters, no? Something
Yeah,
like
here on the screen, you can see the screen. So I'm saying that 12th, 13th, 12th, 13th, these are the two chapters which has been done completely. And the 14th reading, we have done 60% of it. So I'm saying that by the next class, when we meet, just practice these chapters.
okay, ma'am.
And if you have any doubts, then you can ask.
Next class we will be continuing book 2 only.
Every class will be book 2 unless and until book 2 doesn't finish.
And what are the important chapters, ma'am?
We'll do that later. Okay.
Okay.
Okay, guys. So thank you. See you in the next class. Bye-bye.
Thank
Bye
you,
bye,
ma'am.
ma'am.
Thank you, ma'am.
Ma'am?
Yeah.
Yeah, ma'am, this is Aditya. So for the past three sessions, actually, whenever you teach practical, na, like I understand the concepts because I've done them before, but most of the work just goes over my head. So I'm not more of a practical guy, I'm more of a theory-based person. So theory is perfect. So what can I do to make my base in practical strong as well? Because right now the formulas or whatever practical you have taught me, like I understand the basics of it, but if I had to do it on my own or if I had some other uh, numbers to apply to it, I wouldn't be able to do it perfectly. So what can I do to like strengthen my base? Should I?
So, yeah, I got your point. So what you can do is okay. So you can read the Schwarzer book. Okay. In your Schwarzer book, and in your analyst prep also, you have concepts to be built. So what I would suggest is read the concepts and then read the questions, read the concepts, and then solve the questions. First, do the reading of everything without solving. Read the solutions also, read the questions also. Read it. You're good at theory, no? So you will read it. When you read it, you will be understanding some bit of it. Now you do a second read. In the second read, start trying to figure out whether you have understood certain things or not. If practically, if theoretically you're not able to understand, then you can reread. If practically you're not able to understand, then you can resolve. So there are every types of question available. So you have to solve those questions. You have to solve them many times than other candidates because you have identified your strength and weak areas.
Yes,
Getting the
ma'am.
point?
And one other doubt, I've
Ah.
noticed that since this is the second week, I'm not actually able to study per se, like in the weekdays, because I'm working as well. I have my college and I'm working. So I usually get off at like 8 or 9. So I don't have any time to study except Saturday and Sunday, which usually goes by fast. So I don't get the proper time to focus on the theory parts or any like reading material. Could you suggest something in that matter as well?
No, if you don't give time, then what can I suggest? You have to give time. Or you can delay your attempt. That's all what you can do.
Okay.
Correct. Because
Yeah.
6 months of dedicated time you need to study. If you're not able to study, if you're not able to give the time, that's one reason why people don't attempt only. So if you have enrolled for exam, you have to find time to study. No, that's the basic that you need.
Okay, ma'am. And just one other last thing. Like, I just heard someone say that we won't get any test per se, question papers or some test material. Like, we won't get those question tests after you
They are
complete the
there on
chapter
the
or something.
analyst prep. No,
Yeah, yeah, they are there in analyst prep. But what would you recommend? Like, should I do them after every chapter or should I do them after some time? Like, something, some guidance in this matter.
you can do it after 2 readings. After 2 readings, if you are able to solve the module questions, the ones which are there in the book,
Yeah.
if you are able to solve them, then you can go and attempt the other ones. If you're
Okay.
not strong on the concept, then there's no point in going to practice questions, correct?
Yeah. Okay. Thank you so much, ma'am. These were all of my questions.
No problem.
Thank you so much.